talk about expressions with exponents. And again, we're doing this because we're going to have to manipulate these expressions when we start doing some calculus stuff. Right, Mr. Haas?
Calculus.
Yes, can't wait. All right, so negative exponents. Students get confused about negative exponents. What do they mean? Are they negative? It's just a notation. So let's just refresh our memory about how you would simplify an expression like this, right? X to the fifth divided by x squared. Well, I like just thinking about what that means. And that means x times x times x times x times x in the numerator and x times x in the denominator. And then I can divide. X divided by x is 1, x divided by x is 1. That leaves me with x to the third. Now, of course, you're probably thinking back there, Mr. Haas, you might be thinking this, but isn't there a shortcut? What's the shortcut, Mr. Haas?
Well, I suppose you could just subtract the exponents.
Sure. When the bases are the same, you can think x to the fifth divided by x squared is just x to the 5 minus 2, which is 3, right?
That makes
X to the 5
sense.
minus 2.
I love it.
All right. I think you can probably see where I'm going with this, Mr. Haas. How about if I have x squared divided by x to the fifth?
Well, let's first try it the first way you did it there.
Okay, so I have
X times x
times x, and then x times x times x times x times x in the denominator. X divided by x is 1, x divided by x is 1, and I'm left with 1 over x to the third. Hey, can I use my cool little trick?
Yeah.
Sure, let's do it. So this is going to be x to the 2 minus 5. Oh, hold on. What is 2 minus 5?
X to the negative third? What?
Ah, so I guess x to the negative 3 must mean the same thing as 1 over x cubed.
Yes, in fact it does. Please do not think that it has anything to do with negative values. That's not what it means.
It's
you know
not
what I
a
mean?
negative value. It's just a notation that says that x to the third is really in the
But
denominator.
sometimes students will think, like if you say, what's 2 to the negative 3, they will come up with some negative value. Oh, it's not negative. It just means 1 over.
Yeah, so if I have 2 to the negative 3, that's not anything negative. That's just 1 over 2 to the third, which of course is 1 over 8. Hey, what if I had 1 over 2 to the negative 3? What the heck would that be?
Guess that's the same thing as, bring it upstairs. I was going to say 1 over 2 to the negative third,
Right.
which is in fact, right,
That.
2 to the third over 1, right.
Very nice. Yeah, so basically when you see a negative exponent, that just means you're moving it.
Moving on up.
Move
or
it
down.
on up or down, wherever it isn't. Okay? And you know, there's another way to think about why this makes sense. So just indulge me for a moment.
Yes, I would love to.
If I if I have 9
I can't
to the
go
1,
anywhere. I'm filming this thing, so, right.
all right, etc. I'm not going to go crazy here. Dot, dot, dot. 9 to the 1, I think we can agree is 9. 9 squared, I think we can agree is 91. What's 9 to the
81, but that's okay.
I
Yeah.
mean,
You wrote
81.
81, yes. You said 91, but that's all right. Yeah, 81.
What's 9 to the 0 power?
Well, 1, anything to the 0 is 1, of course.
I mean non-zero to the, right? So what would 9 to the negative 1 be if I'm continuing this pattern?
Ah, I guess that would be 1 over 9.
Yeah, see how nice that works? You still getting me over here?
Yep.
So you can see that there's a pattern here, so it kind of makes sense. Hey, that leads me to my next thing that we're going to talk about. What would 9 to the 1/2 equal?
Well, certainly it must be between 1 and 9 somewhere.
Yeah, exactly. And if we recall, fractional exponents are another notation for a square root. I don't need to put that 2 there, but a square root, which means that would be a 3. Okay? So all of these weird exponent notations really make sense when you stop and think about it. Okay? So what we're going to do in the following couple of examples is just rewrite expressions that have negative exponents and that have radicals or fractional exponents. Doesn't that sound like fun?
Sounds awesome. I love it. And there's a reason for this, of course.
Yes.
And there's many reasons for this, but there's an immediate reason for this. But very soon we're going to be working with negative exponents and positive exponents, for that matter, when we take the derivative in calculus. So
The derivative?
Yes, the derivative.
Ah.
So you'll have to be very comfortable working with negative exponents and positive exponents. Let's just say exponents. Can we say that?
Let's do that.
So I'm just asking you to rewrite these with positive exponents.
Okay.
And as Ms. Stewart said, there are reasons behind these rules, but the rule is really quite simple. If I see a negative exponent and I want to make it positive, I can just move it to the other side of my little fraction bar.
How
so I'm
easy
just
is
moving
that?
from downstairs to upstairs. I'm going to rewrite this as 2x to the 4th over 3. And just to be really clear, the 2 stays where it is, the 3 stays where it is. The only thing that moves is the guy raised to the negative exponent.
Totally makes
Sometimes
sense.
students want to drag that 3 with them. Stop doing that. 3 stays where it is.
Good.
All right, let's go to this guy. I have a 4 and a 3. Again, the 4 stays where it is, the 3 stays where it is. I'm just bringing this whole big bad boy down here, and that is 4 over 3. X to the positive 2.
Beautiful.
Am I doing so far?
Yeah, because only the x is being raised to the negative.
Yes, that's what I'm
So,
saying. Right.
Beautiful.
Sometimes this bothers students. I'm not
Right.
sure why. Let's just put the whole thing over 1, shall we?
Yes. Do that.
I'm going to move this guy downstairs. I have the 1. I don't really have to write the 1 again. I mean, this is x to the positive 6. I suppose I could write a 1 in front of that x.
Very nice.
Not necessary. Also, something that bothers students a little bit. Now I have parentheses. Sometimes students just drop parentheses. Stop
Yeah.
doing that. This whole thing is in parentheses. This whole thing is raised to the negative 3rd. These guys are attached. I'm going to move this whole guy downstairs.
Right.
Here we go. This is going to be a lot of work. 5 stays where it is. 2x to the 3rd. What's upstairs?
Ah, I think a 1 has to be
1,
upstairs.
in fact, is up there.
Very nice.
Now I can simplify this a little bit.
Sure, let's do that.
This means 2x times 2x times 2x. It doesn't, it's not just the x cubed, the whole thing.
The whole
2x
thing.
times 2x times 2x is 8x cubed. Let me write that. 5 times 8x cubed.
Beautiful.
And in fact, I can multiply 5 times 8, and I get 40. You still got me?
I do.
1 over 40x cubed. Now I'm just going to go around the other side there. And then
Perfect. And that's it.
Thanks,
Very
Ms.
nice. So now we're going to do something else, and that is to rewrite each one of these expressions in the form a times x to the b, where a and b are just some numbers, okay, some constants. And this is not arbitrary. This is going to be a very handy skill when we get to taking derivatives.
Calculus.
Calculus! Can't wait. So let's just start with this guy right here. 2x squared over 5. I want to write it so that it's some number times x to the b. Well, I think we can see the number is just going to be 2/5. That's the coefficient. And now let me think about this. X squared, it's in the numerator. Is that going to be the same as if I just put it next to it?
It is.
Yes,
and
it
for
is.
some students, this is bothersome.
Yeah,
I don't know, you have to get yourself to see that as the same thing, I guess.
right. Now, one way to think about it is, well, you can always think of x squared as being x squared over 1, which means it's in the numerator. Right?
So if it's on the top, you can just move it off to the side, it means the same thing.
Yeah, and you know, sometimes I like to say, all right, if I take 10 and I divide it by 2, is that not the same as taking 10 and multiplying it by 1/2?
That is the same.
So if I have an x and I divide it by 2, that's the same as taking half of x. So when the thing is in the numerator, when the x is in the numerator, that's the same as if it's just right next to it.
Got it.
Okay?
I
Good?
think I got it now, Ms.
All
Stewart.
right, good.
I always get that mixed up.
All right, so we're good with this guy. Now, let's rewrite this in the form a times x to the b. All right, the coefficient is my 3. I want an x. So That means this guy needs to come upstairs. When I bring it upstairs, that's going to become a positive exponent. Beautiful.
That works? Yeah.
All right, here we go. A times x to the b. My coefficient is going to be, you have to think about a little invisible 1 there. It's not 8, because that 8's in the denominator. My coefficient would be 1/8 times x to the, holy camole, that's a radical. How do I rewrite radicals using exponents? Can you refresh our memory, Mr. Haas?
Well, it is the cube root. I like to think of it as the cube root of x squared. So
Got
that
it.
would be x squared cube rooted or over 3.
Very nice.
I know some students have some weird memory thing. I forget what they, I don't know. But I just like to think of what's happening.
That makes sense. You're squaring it and then you're taking the
cube
cubed
root.
root or the third root. So you're taking a third root.
Right.
Yeah, very nice. All right, and over here we have our a, our coefficient. I think we can see clearly that's going to be -2/3 times x to the, now I just have to figure out my exponent. I've got to do two things here. I need to move that up into the numerator and I need to rewrite that. So that's x to the 5/7. So that's going to come upstairs to be x to the -5/7.
Right, and you wrote it on the side because that's the same as upstairs. You didn't do it in 2 steps. That's very tricky.
Yeah.
Yeah, very good.
How do we feel?
That's great.
Wonderful.
I want to do 4 more, Miss Stewart, just because they are so much fun.
They are fun.
They are fun. There is a reason for this, which again we will get to, but I am rewriting them in this form: some number times x to some exponent. You will use this when we get to
Derivatives.
calculus.
Calculus.
Derivatives, right. So of course this is a 1 over x to the square root of x, which is of course x to the 1/2. I want to move this guy upstairs. I'm going to do it maybe in a couple of steps. I'm
Sure,
going to
let's
move
do
this
that.
whole guy up with the 1. It's really a 1/2 here. I'm going to change this to a -1/2. I guess I'm done. I mean, I could leave the 1 if I wanted to, but you know what? I'm just going to rewrite. I'm going to get rid of that. I didn't give myself a whole lot of room here, did I?
That looks good.
I'm just going to rewrite it like that.
Very nice.
All right, here we go. Here's another one. I'm going to write it as some number x to some exponent. I'm going to move this guy upstairs. 2 stays where it is, as does the 3. You know, I really could move the 3 up there if I wanted to and say 3 to the -1, but that's not helping me.
No, that's horrible.
No, that's
yeah.
screwy. I want a number, here's my number, times x to the -5/4. Again, I'm moving it upstairs. You know, if you write it on the side, that means it's upstairs.
Very
We did
nice.
this already, I think, didn't
Yeah,
we?
we did.
Yeah.
And sometimes students get freaked out because that's a fractional exponent, but you still just make it negative, just like anything else. Yeah,
Stuck a negative in front.
love it.
Ooh, yeah, you got a tricky one for me, okay.
Sneaky.
This entire thing is being raised to the -2/3 power. I mean, if it helps, I guess we could rewrite it first as a positive so you could see it and then simplify it that way.
You
I
do
mean,
this lots of different ways.
Really,
so let's try
do it a
that.
couple of different ways. So I can move this downstairs. This is really 8x to the 2/3. You buy that so far?
Yeah, looking good.
Which is really 1 over 8 to the 2/3 times x to the 2/3. Well, what's 8 to the 2/3? That means 8 squared, which is 64. Cube rooted, what times what is 64? It's 4. Which is the same thing as saying 8 cube rooted first. The order doesn't matter. I can cube root it, which is 2, because 2 times 2 times 2 is 8, and then squared, which is also 4. Comes out the same.
It is.
8 to the
Fantastic.
2/3 is 4.
4.
You know, that's the kind of thing you should be able to do actually without a calculator.
Absolutely.
It's going to be a big one.
Yep.
X to the 2/3. I still have to move that x upstairs. Is it okay that I'm doing this in so many steps? Ms.
Yes, I
Stewart?
think it's
Okay.
great.
X to the -2/3. So I just brought that guy upstairs. Is that too messy?
No, that's beautiful. So then you made that negative because you brought that upstairs, which is just next to it.
That's exactly what happened.
Beautiful. And one last one there.
One last one. I'm just going to move this guy off to the side. This one sometimes bothers students also.
Yes.
It's really a 1 in front.
Okay.
1, 5. I'm just going to move this guy to the side. Do I change the exponent to the sign rather?
You don't, because you're just, it's the same thing. Upstairs is the same as next to it. So you really didn't do much except.
I did not do much of anything.
Transfer.
I just slid it right off the side there.
Beautiful.
That's all I did.
Thanks so much.
Yep.